Yes,
I will record this.
Interrupt.
Cool. Thank you for the reminder. Was that Mary that just talked?
Yeah.
Okay, thanks, Mary.
The person like send.
Yeah.
To
Thank you, Anish, as well. Okay, so I will. I'll open up a console here, so we can sort of jump into this. All right, I've switched it to this. I'm not sure if you guys can see my desktop. Can you guys see my Chrome screen? Give me some thumbs up. It's always hard to tell over Zoom. So I'm guessing that you can't. Okay, great. All right. All right, so just sort of going over the basic idea. We have our two kinds of sort of very basic functions that are used in JavaScript. And so we have our initial way of declaring functions, which is one that you've seen before in various different ways. So using the canonical example of the adder, we're going to use, we have our function header, including, the semantics of the function as well as the name of the function. And we also have its various arguments. So in this case, we have two parameters to the function x and y, and we're going to say return x plus y. So we just have our two sort of input variables, and we're just returning an output, which is a sum of the two. Yeah.
I just had a really quick question. Are we supposed to be seeing the slides?
No, you're supposed to see my console. Are you seeing that right now?
We're just seeing like a new tab on Google.
Okay, you're not seeing the JS console or anything like that?
No, I'm not seeing it right now.
Strange. Okay.
But is this actually my part? Is anyone else seeing it?
Yeah, it's just a Google Chrome.
Yeah, it's a Google, right?
Yeah.
Okay. Yeah, now we see it. Okay, we see it right now.
Now you see it.
Sorry, I was just a little confused.
I don't know why that's happening. I did share that screen, but there's like another window that has just this tab on. It's super weird. Okay, whatever. Thank you so much.
Thank you.
Yeah. Great. So this is the function that I was talking about. This is a very simple way of declaring a function in JavaScript. We have our two parameters, and then we have our return statement, which is just simply the sum of the two input variables, x and y. So we can use adder as so. We can say 1, 2. And you guys do know that we can sort of access the console. This is actually like a website called JS Console that I like, just because it displays in a very clean way. But no matter what website you're on, suppose we're at webdevatberkeley.org, we can sort of access the console by going to inspect tools and then going to our console. And we can sort of do the same thing here. And these two things are equivalent. There is another way to sort of define a function. So we have an arrow function. So if you know what a lambda function is or an anonymous function is, lambda in Python and then an anonymous function in other languages like Java. And it's used in order to sort of truncate code and also use it inline. So there's various different functionalities for arrow functions, but in a way, it's a shorthand for writing function definitions. So here's just like a really quick example of it. So if we were to, yeah. Okay, it looks like some people have their volume on. Make sure that you're muted. So yeah, really simple way of sort of creating this arrow function. So if we were to sort of, let's say, let adder equals, and then we'll define adder as being as having the inputs x and y, and then we'll make it an arrow function. Oops, making an arrow function with an output of x plus y. So you can say return x plus y. But instead of that, in an arrow function, you just say x plus y, because we're assuming that our function won't have any side effects. I'll explain what I mean by side effects, but essentially we're saying that there's only one sort of probable outcome of this function. And so in that way, it's like very deterministic. So if we use adder again, on this 1 and 2, it works with this new function definition as well. And in this way, we've sort of abstracted away the function into not just like a function declaration, but a variable that can be used within other function calls, or it can be used within the context of an object. So it sort of, yeah, I guess it sort of abstracts away our process a little bit more. And you might find many different use cases for it. One particular use case in React is to allow you to sort of build stateless components very, very easily, very, very quickly. So yeah, does anybody have any questions on these two different types of functions? Cool. Okay. I think that some people are not muted, so I'm just going to go ahead and mute everybody. Feel free to unmute. Raise your hand and then unmute if you have anything to say. Okay, so we just went over functions. I know there's like 1 or 2 people that just joined. We just went over functions. We went over a regular sort of function definition, which looks like this. And then we also went over an arrow function. And so this arrow function is a way for us to sort of just specify the outcome as being one singular thing. We can also define, I guess, this arrow function in a multi-line way, which might also prove useful. So it looks something like that. And then in this case, we would have our return statement. And so it would look a lot similar to the initial way that we defined the function. So yeah, so in this case, it says adder has already been declared because we just used it. So let's redefine it to be adder1 or something. Adder1. There we go. And then we can say adder1, just like before, on 2 numbers, and we'll get the same idea. Yeah, Mira, go ahead.
So I was just kind of trying to make an analogy. It's like the best use of like defining a function using let in JavaScript, similar to like it doesn't really take up that much memory or something. Like lambda, or like I guess what's like the best kind of use of using let?
Yeah, we are going to talk about that later in this lecture. Good question. Let is just a different. It's a way of sort of defining a variable. It's just a syntactical tool to define a variable. There's different use cases for using let versus var versus using const. And all 3 of those things can be used to define an arrow function. So an arrow function is just a variable like any other variable.
Okay.
Yeah. Any other questions? Okay. Yeah. So one thing to note is that the arrow function will not have its own this keyword. And so like in this case, it won't have like the function keyword. And if it's attached to an object, you can't define it in the scope of an object either as being an object method or anything like that. So we can't sort of initialize it, use any sort of new methodology. So just something to note. In that case, we would have to use a regular function to accomplish the same goal. But again, this can be sort of created inline as well. So if we had a function which took in another function, for example, we could define the adder function just as the body of this adder variable definition. And that would allow us to sort of use that function within the function call itself of a higher order function. Okay. So just to move on, I guess. So the next main topic at hand is scope. So scoping in general is, I guess in computer science, it's our abilities to sort of define the accessibility of various different types of variables. as well as functions and objects in order to make them work in different contexts. And there are rules in different programming languages for different kinds of scope. But in general, the broad sort of definitions of scope tend to be within global, local, block, and lexical scope. And you can see this in the notes. But global scope is essentially scope that's defined outside any sort of function or object bounds. And it's able to be accessed usually by local scoped variables as well, or locally scoped, I guess, like functions or anything like that. And then block scope is anything that is sort of like enclosed within curly braces in a non-like functional context. So like while loops or if statements or anything like that, we would call that block scope. And so obviously that can occur within a local scope as well, but it can also occur outside of it. And then we also have our lexical scope in the case of a nested function or anything like that. And that has its own obvious sort of use cases for not being able to use the variables that are sort of defined within a nested function outside that nested function. So in terms of global scope, let's just have an example here. So we'll say, we'll define a variable with my name in it. So we can obviously access this in the global scope. But if we were to create a function called getName, I guess, and oops, next line. Can we sort of access name outside of this? So that's the question for you guys. Do you think we can sort of print out a name inside of this function, or will it sort of raise any sort of error? Feel free to sort of write it in the chat or anything like that, what you think will happen. Great. Yeah, the answer is in the notes, but you can definitely get name inside of a local context because name is defined in a global context. So you can access global variables even within a local scope. So the opposite actually cannot occur, as you might be able to guess. Variables or functions or objects even that are defined within a local scope cannot be accessed in the global scope or cannot be accessed in other local scopes as well. And so this is something that you're very familiar with, this whole idea. If you've taken 61A or any of those types of classes, they dive into this very in depth. So, but it is a little bit tricky to understand at first. Feel free to sort of ask me right now or ask anyone in office hours if you have any questions with this. And another sort of important idea is this idea of block scoping. So any sort of like if statement, suppose we say if 1 equals 0. Let's just say if 1 equals 1. Why do I keep doing that? We will define a, let's actually try defining name again. So we'll say probably 1. And so the question is, are we allowed to sort of redeclare this variable within the function? And so yeah, feel free to add that in the chat. And I see Chia Chen, I don't know if I'm pronouncing that right, sorry. Can you explain a little bit about the difference between the double equal sign and the triple equal sign in JavaScript? Yes, I can. So you might have seen that before, and we actually are going to go into that in the first React lecture, I believe. And I think I'm going to be teaching that as well. So I will teach it again, but the triple equal sign is preferred just because in JavaScript, sometimes JavaScript acts a little bit weird when it comes to mutating types in order to fit things together. And so, for example, if you're trying to compare a string and an integer, you obviously don't want a string to be equal to an integer no matter what the strings and the integers are. But in certain contexts, JavaScript actually forces the integer to become a string in order to fit sort of the equality operation. And so it will sort of say that they're equal. And there's different cases where JavaScript screws up in this context. And so like you can try to compare or add two numbers together that can't really be added together. And it just works because JavaScript casts everything under the hood. So that's one reason why in many cases you wouldn't use the double equal sign, because it doesn't work the same way as it does in other programming languages. So in order to avoid this forced type conversion, this is one of the biggest reasons for using double equals or triple equal signs. I guess that's that triple equal signs allow us to sort of compare two things like exactly as they are. So in the case of this right here, if I did something like that and I did two equal signs, it would actually make this true and it shouldn't be. But if I use three equal signs, it would this expression right here would result in a false value. So in general, I say unless there's like a reason to use double equal signs, it's just very, very infrequent. Always use triple equal sign in JavaScript. And so we have our we have this expression, and then we have the triple equal sign expression. But I think we just have this and this for greater than and less than or equal to. Does that answer your question? Great, cool. So yeah, what do you guys think is going to happen if I execute this block of code right here? This one. Not all at once. Okay, so if I execute this block of code, it will actually change the name. Even though it was sort of globally defined, I can redefine name to be equal to something entirely different just because it's a var and not a constant variable. So we're actually going to be, I think this is the next topic, but just sort of want to introduce that. There are limits to this sort of scoping thing, and you can access and modify even outside variables within a block context. Yeah, so like, but generally speaking, things defined in things like if statements and while loops don't really influence anything outside of those. So yeah, so like, let's see. I don't know why it's like being weird for scrolling right now. Let me just refresh the page. Okay. Any questions so far? Okay. But yeah, just if it wasn't 100% clear before, I'm going to do it again. So why do I keep doing that? So if you sort of define something using a var, so if I say var x equals 1, and then I say, let's try using the other two different types of variable assignment operators, which are let, and to keep it simple, we'll just use these three very simple variables. And the third one is const. All of these you've probably seen before, and we're going to say z is equal to 3 here. And so the idea with block statements is that variables that are by nature locally defined cannot be accessed outside of the block. So that means that if I were to log, I have a new keyboard, so sorry if I'm typing very slow, but if I were to log x, it would work because var is by default logged in like a global context. If I were to log y, on the other hand, something different might happen, and the same thing with z. So the first sort of error that we get is that y is not defined. And so it throws the error first, naturally. And that's because it sort of scans everything for syntax errors before actually executing the code. But it doesn't sort of log this as well, but it does log y in this sort of read eval print operation. It does go through this first and it logs x because x is a globally scoped variable. Var is by default globally scoped. Sorry, I should say in like a global versus block scope context. On the other hand, we have our lexical scope in JavaScript. So yeah, anyway, if I were to try to sort of print out Z, the same error would occur, just for reference. A lexical scope means that a variable outside a function can be accessible inside another function defined after the variable declaration. So in other words, if we were to define a function within another function, our child function would actually get access to our parent's function's variables, but not the other way around. I'm not going to type that out for now, just because it's in the console, but I hope that makes sense. So basically, a child can access a parent's or a higher function sort of variables, but it can't, and a higher function cannot access a child's variable function, child function's variables. So this is very similar to how global scoping versus local scoping works. At a local scope, you can access globally scoped variables, but not the other way around. Okay, I hope that makes sense. Let's talk about the this keyword now. So this is often used or almost exclusively used in object-oriented fashion. So let's see. I see a raised hand. Before I move on to this next topic, I'll answer these questions. So why not use var every time to make things simple? Very good question. So this, and Mira, I'll get to you after this as well. So var is basically, so I guess the question being asked is, why not always use globally scoped variables and things that can be sort of modified at will? And there's many different reasons to want to prevent those layers of abstraction from being broken into. And so like one very clear one would be like if we were to try to sort of hide some inner information and sort of not let some sort of function that's used by another client operation to modify something that occurs in a global or like a higher lexical scoping than this current one. In that case, then using var would allow us to sort of modify things at will if that function can be redefined in a different context. So using let is often actually the safest move. Let sort of confines us to using scoping appropriately, but also at the same time, it like doesn't sort of throw us any errors when we're trying to redefine things. Because const will throw errors. Const is sort of referring to a constant variable that shouldn't be redefined. So if I were to type in like const z equals 3 and then I typed const z equals 4 after that, it would throw an error versus let y equals 2, let y equals 3 wouldn't return that. So let is like a good balance between flexibility and a little bit of rigidity so that things aren't just like modified willy-nilly. Even in the context of like Python, there are very strict rules to prevent information from flowing places where it shouldn't flow. Does that make sense? Yeah, let me know if that still doesn't make sense and I can try to give an example, but yeah, I think this will definitely come with a little bit of practice on that thing. Okay, Mira, ask your question.
Yeah, my question, I mean, I guess you kind of already answered it. I was just really gonna ask like the difference between like let and const in terms of scope, but I guess what I found out is that like const you can never reassign it, but in let you can still reassign it. It can only be called in like the same area it's kind of defined in. Like if it's defined in a function, it can only be referred there, right?
Yeah. So I mean, in the same, so it's not necessarily like immutable, right? So if I were to sort of say like const x equals ABC, I can still say ABC equals DEF. I can still do that. And then, or I don't even know what I just did there. My bad. So I can still say, so yeah, in this case, in this particular case, I typed in const x equals ABC, and then I did the same thing again. And you might recognize this from like other programming languages. Obviously, this would run into some sort of error. But if I did this using let, this same exact function would not give me an error. So the same exact operation, I mean. But if I were to do something like x is equal to def here, it would give me a type error, which is like a different sort of error. And it would say there's an assignment to constant variable. You're not allowed to sort of do that. You're not allowed to assign it a new value. So in that case, you're correct. Constant variables are often used for like object definitions as well as definitions of arrow functions, which we've seen before. And in the future, you'll see sort of React components and things like that, which are often used. You often use constants for that because you don't redefine them, right?
Right. So like
Yeah.
you can never redefine a constant variable.
Yeah.
So I'm thinking of like kind of like tuples in Python, I guess. But like you can't. But you can define like a let variable again. But like let is also like not as like it's not a global scope like var, right? It's only okay. Yeah. That's what my question basically is.
Perfect. Yep. Exactly. Any other questions? I will say that like I often like almost always use const for like writing React code, but in terms of like writing some server-side scripting, I often use let. Let allows us to redefine in the same scope, unlike var and const. Yes, correct. Cool. I hope that answers those questions. Okay, great. So let's talk about this now. The notes say that it's a keyword that refers to the object it belongs to. And I guess, yeah, that's a pretty decent way of putting it. But we want to think about so this you might recognize from other programming languages as well. I think Python has self, Java has this. So JavaScript also has this in a very similar way, although it isn't sort of object-oriented in the same way as those languages are. It still does have those object representations that can be accessed using this keyword. So if you use this within the method of an object, you are referring, similar to self in Python, you're referring to the object itself that it's contained within. But if you use sort of, let's see, so one thing to note that we've already sort of talked about before is that arrow functions cannot be used within an object context because you can't use this keyword within an arrow function. And so just to use this example, and just to sort of type it out explicitly, we have this object that's defined in a JavaScript way. This is how JavaScript defines objects. We can say var here, we can also say const. In this case, I'm gonna say var so I can modify it later. I'm going to define an object in a key value pair sort of manner. So I don't know if you guys have seen this sort of thing before, but actually, I guess this website has never behaved so strangely. I'm going to just refresh the page every time I go to the end. So if I define a new object, I have to define it using key value pairs. I, in this case, would be an object attribute that gets automatically assigned to a var, and then I can access it later. And so if I say I is equal to 10, as in the notes, we can see that, and then I'm going to define another function called, I'm going to define an object function or a method called b with sort of a body of a console output. So you might see this in there. So this dot I, this. So this actually spits out the object itself. And then this dot I would refer to the I attribute of the object itself. But if we were to try to do this same operation within the context of an arrow function, it would return an error because arrow functions are meant to be defined in a global scope. I'm just emphasizing this so you guys don't run into issues later on, because I have. So this will sort of give us object dot b will return the output of that console call. So we see 10, which is the attribute I of object, as well as the object itself, and so a reference to the object itself. And this is the object. Okay, cool. So yeah, this is also how objects are represented in JavaScript, and we will see this actually in action in a little bit. So yeah, actually, this is interesting. So if I just type in this right now, it'll say window. And that's because in the context of sort of JavaScript within the DOM, you have our entire document referred to as the object in question. So the window is what is the object that we're defining all of these variables within. So that is essentially our global scope. So in this case, it's object window, and you see all of these sort of functions that we can use. And so there are functions native to just the window itself. And you can also call functions of attributes, which in themselves are objects within this. So if I say something like document dot, I think it's design mode. Yeah, so let's see if I can do that in here. I think that's what it is. Document dot design mode, yeah, equals on. This is one way to sort of use this idea that I'm sort of introducing right now. And so by default, this design mode attribute of the object document, which is in itself an object that's contained within the window global frame. This can be modified to be anything we like, so off or on, obviously. And if you redefine it to on, you can modify the page at will. So in this case, we can sort of say, we can add in whatever we want. You know, we can modify the text that's on the page. And this actually comes in handy quite a bit when you're trying to code monkeys, JavaScript developers, whatever it is. You can sort of modify it at will, and then you can see how different text and different sort of buttons work on the page. And so as you start developing, you'll find all of these different tools hidden within the global context, hidden within the document itself. So just wanted to sort of point that out. So we want to say that this in arrow function is another sort of way to use this. So I previously mentioned that you can't use this within the context of an arrow function, but that's only within the context of an object. So if I were to try to say that, if I were to sort of define a variable that, or an attribute of an object within a function itself, or within sort of a global scope, in this case, if I were to say function modify, I'm just gonna say mod with no parameters, I can sort of define my own variables in here. So I could say this.x equals 3. And then I can say, you know, let's see, so let's use this example actually, because I do want to introduce timeouts. Yeah, we'll say set timeout, and we'll use an arrow function here. And so this is an example of how to use an arrow function within the bounds of like another function call. So in this case, I'm using a set timeout function call, which we'll learn about in a second. And then we're using a lambda function or an arrow function within it to log out the value of x within the set timeout. So set timeout just specifies a certain amount of milliseconds to wait for that function to execute before returning the output. So in this case, the output is console.logging this.x. And yeah, and then I can surround this with curly brackets. And then I can specify a certain amount of milliseconds. And then finally I can post the function itself. So I can say mod and call that. And that will wait for a little bit, and it's supposed to log that out. So let's see. Okay, yeah, we just had to wait for a second. So after 500 milliseconds, it actually does spit out 3. And again, this only works in the context of a locally scoped thing. So if we were to use, if we were to say something like, yeah, if we were to define this .x outside of the function call, outside of the function definition, and we didn't use an arrow function, we would get the globally scoped this .x rather than the locally scoped this .x. And so I hope that distinction makes sense. And the fact that we can only use this .x or references to attributes that are defined within a locally scoped function, if we're sort of using an arrow function in that way. Yeah, that was a little bit confusing. Mira, go ahead.
Sorry, I had a quick question. So for this .x, like we didn't do any object.mod. So like which object is it working on? Like what exactly does this .x represent?
Right. So we have our this in this case. Is that what you're asking? What this means?
Yeah.
Yeah. So this is not referring to the function, because you obviously can't do this referring to a function. And you correctly identified that there is no object, but there actually is an object, right? That we've just talked about a little bit before this. The object is the parent of function, which in this case is the global window object. So it's modifying the X variable on that. So wherever you're sort of defining your function, it just searches the level higher above it to see if there's an object available. Otherwise, it just modifies the global scope. Something referring to the global scope. Does that make sense?
So basically, because we did var object equals, and we defined that, and then we made this function which was doing this .x, it just assumed that like if you didn't like objectively call it with a specific object, it would look for objects above it. It looked for the var object that we defined, and that it gave it an attribute and like called that. Okay.
Yeah, so that's the initial assignment of this .x. But again, if we sort of change that outside the function, it will only change it outside the function. And so, yeah, I guess that's one way to sort of define things and be able to change them within functions, similar to like non-local in Python.
Okay.
Yeah, Kelly, go ahead.
Sorry, do you mind explaining the timeout function real quick again, please?
I will actually explain that in a bit, in depth, because we're going to be talking about asynchronous functions. So
Okay, thank
I'll
you.
explain timeout. Okay. Can you guys still hear me? My computer, my monitor just died. So. Can you guys hear me?
Yep, we can.
Okay, great. Super weird. Not sure why that happened. Okay. Great. So okay, 1 second. It's still giving me a battery error. Give me a minute, sorry. Okay. Technical difficulties resolved. Great. Okay, so now to get to the topic of timeouts, I guess. Let me just make sure my Wi-Fi is still on. Okay. To get to the topic of like asynchronous functions, I'm going to transition to the slides real quick, just because I think they do a pretty good job of explaining what it is. So first, let's talk about synchronous processes. Again, give me a thumbs up if you do see my slides right now. Great. So synchronous functions are sort of the default mode of executing statements. So you might be sort of used to this in Python, executing the statements essentially in sequence. And so we take it line by line and sort of execute everything one by one. And so in the console, you might see like me define like an assignment or anything like that. And then it sort of moves on to the next line only after the previous one has finished executing. I guess an issue that you might see with this is that like a long function call will block the operation of the thread. So what do we mean by thread? Well, we mean sort of the system that allows us to take and the system that handles all of these calls one by one. So if you've taken 621A, you sort of know what I'm talking about here. But if you're trying to execute a bunch of statements, your compiler or whatever is sort of, or your interpreter, whatever is sort of trying to execute your code line by line, will try to execute it line by line. And so the only way to subvert that in the case of having one statement that takes a super long time and other statements that might not necessarily depend on the result of that previous statement is to sort of separate these threads into distinct threads that take these operations as they come. So while one thread might take care of a particularly long operation, other threads might take on the mantle of taking on other processes. And we'll see this in action in a second, in the case, in like a JavaScript context. So those are synchronous calls. And then asynchronous calls are those sort of multi-threaded operations that I was just telling you about. Instead of sort of having everything done on one thread, it allows us to sort of split things up and have everything done on its own time. And asynchronous functions are very important to web development because web development relies on sort of making these calls to APIs or other sort of backend servers or services that take a while or do not take a deterministic amount of time to output. And so the very basic version of this is set timeout, which you might have, which we talked about a little bit earlier. I think Kelly pointed out. The set timeout is one of these sort of core asynchronous functions that are native to JavaScript. So we have set timeout, which waits a given number of milliseconds and then calls a function. So we saw an example of that here in the console. Right here. So we saw an example of that right here. So set timeout, and then we have a lambda function in here as the first argument. The second argument is the number of milliseconds. What this means is that this first argument is the function, and this function will only execute after this allotted number of milliseconds has been completed. And of course, we can nest this in a way that allows us to only perform operations after other operations have been completed, sort of making synchronous operations happen within an asynchronous context. So yeah, we can, and so the idea of sort of differentiating these functions into asynchronous and synchronous and sort of handling these asynchronous functions differently is referred to as handling callbacks. So yeah, so we can nest multiple of these callbacks within one another in order to handle asynchronous data that is potentially sort of disparate. So if we want to fetch the data from a server and then process the data and load it to the user, all of those might involve a different set of callback functions that all might occur in their own span of time, but it might still rely upon one each other, and we can define that. So let's see. Go back to slides. Those are asynchronous functions. And so what is the event loop? I think you guys might have seen this in a different lecture or previous JavaScript lecture, but the event loop is essentially the overarching way for JavaScript to handle any and all calls, whether they're sort of on the client side or on the server side. And what it does is it takes every single request and it puts it in the event queue, and then it executes the function as a queue does. And so the first function that's put into the queue is the first one that gets executed. And so all of those synchronous functions get executed first, then the asynchronous functions get executed on the next turn of the loop. So if we have things like var x is equal to 3, or if we have something like console.log hello world, those are synchronous functions or synchronous operations, and those will get executed sort of one by one first, and then we will tackle the asynchronous functions in the next event loop. But there is a little bit of nuance there. Asynchronous functions don't all happen at once. There's things called, if we have, let's see, so yeah, we have different types of asynchronous functions. There's micro tasks and there's also macro tasks. So micro tasks have their own separate queue within the asynchronous queue. So micro tasks could be things like promises that are, and all these sorts of micro tasks are called before, like right before the next iteration of the event loop. Whereas macro tasks, which are things like timeouts with set sequences, are called at the start of the next loop. So I want to sort of give an example of how this works. But let me answer this question first. So the set timeout function essentially makes a synchronous function asynchronous. Yeah, you can think about it like that. If you have set timeout called within a synchronous, what you believe to be a previously synchronous function, it will obviously make it asynchronous. But you can also wrap the set timeout function around another function and then specify timeout in order to make it asynchronous. But yeah, so set timeout is in and of itself asynchronous. And it's like the canonical example of that. So let me actually type out an example that I think will be quite useful for understanding this a little bit better. Okay, let me refresh the page again. So if I log out, this right here, so let's just say it's the first line. We can expect this to be executed first, but then I'm going to have a set timeout function that takes in some sort of arrow function, and I'm just going to substitute a blank input because there is none. And we're going to specify an output, which is we just want to sort of log something to the console. So we'll say console.log, and then we'll say something like, this is a timeout. Yeah, this is a timeout function. And then we can say, and the set timeout function has to take in a second argument, which is the amount of time that it that will elapse, I guess. Okay, so all of you should sort of be familiar with this by now. And then I'm going to say another thing, which we haven't talked about yet, which are promises, which I guess I just introduced right now. But promises sort of run asynchronous functions in a way that's somewhat deterministic. So we get this promise, which we resolve, and then we get our the output of that promise, which we will compose into its own JSON. So you can say something like promise I guess just promise. And then finally, I'll just say console.log hello world. So painstakingly type that out on my new computer keyboard. I'm going to just define this. I'm going to sort of define line numbers here. And I want you guys to tell me what is the sequence in which the JavaScript console is going to handle all of these requests. Type them out in the chat. Which one is going to happen first, and which one's going to happen second, third, fourth, so on and so forth. Okay, so we have one answer from Kelly so far. 0, 3, 2, 1. Does anybody else have any ideas?
I had a really quick question about like a syntax thing that I was noticing.
Mhm.
You know how inside set timeout, like you do the console.log, this is the timeout
Yeah.
function, and
Yeah.
there's like the special like brackets that we have.
Yeah,
is that like,
we don't even need these brackets if that's what you're talking about.
oh, we don't like what I thought, do they denote something like this is a function or like?
Yeah, so in the case of just having one effect of the function, you don't need you don't need curly braces. So if you know Java, like you can sort of just identify or you can create an if statement or a while loop or anything like that without including the curly braces if there's just one line in there. Similar to
Right.
that, like this is the same idea. So there's just one line, there's just one effect. But if you have multiple effects, then you need the curly braces. Curly braces are optional if there's just one effect.
Oh, but for an arrow function, isn't it always going to be in one line or?
Not necessarily. Arrow functions
Okay.
can happen with multiple lines as well.
Okay.
Okay, so we have 2 answers so far, and they're both 0, 3, 2, 1. Does anyone else have any other ideas? Should there be a console.log round promise? Yes. Thank you. Good call. Okay, so we have 0, 3, 2, 1 so far. Douglas, I'm gonna call you out. Can you explain why you think it's 0, 3, 2, 1?
So I feel like it's easier to go backwards and to see that the timeout is going to happen last because this is going to be the asynchronous function. And then the promise the dot resolve then is going to happen second to last because it has to be resolved first and then the console can log it, while 0 and 3 can happen synchronously where the console reads it and then they just get logged.
This answer is correct. That was a good explanation. So question, is promise.resolve, is that an asynchronous function? Douglas, do you want to take that?
I kind of missed it. Could you repeat the question?
Is this promise.resolve call right here, is this asynchronous?
No, it would be synchronous, but the then would just happen after it was resolved, right? It gets read at the same time as console.log, but it doesn't get finished until after the logs are complete, is what I'm thinking, at least.
Okay, yeah, that's close, I'd say. Yeah, promises in general are sort of ways for us to handle callbacks in object form. So in this case, there was nothing inside the promise that made the callback have some sort of waiting time, but still it's asynchronous. Promises are by nature asynchronous. We'll see examples where the promise will be sort of identified explicitly as having some sort of callback or as being the, I guess, proxy for a callback that is clearly asynchronous. But even in this case, where there is no sort of callback to circumvent that, it is still asynchronous by default. The only difference is that it's a micro task versus a macro task, which means they've already sort of gathered those resources, kind of like what you were implying there, for the most part. But it would essentially be done before the set timeout because it's a micro task, which gets executed before the next event loop. Should there be, is there any other questions? I think Mira raised her hand.
Yeah, I was just kind of confused. What exactly is promise.resolve? Like what is that?
Oh, promise.resolve. Oh, yeah.
Like
I'll
what is
explain this
promise? Like I just don't know that. Yeah.
We haven't explained what promises are yet. So see if one of you guys, is it definitely some sort of syntax error that's happening here? See if you guys can sort of notice what's going on. Maybe it doesn't like the comments, possible. But anyway, so a promise is an object that produces some singular value sometime in the future. And so let me just sort of give you an example of this. Let's say, so I say something like, I can say something like const, right? And I can define variable promise equals fetch. Okay, and then let's take in some random API. Let's find one, xkcd. I think there's one xkcd API or something like that. It's just like random. Yep, it's right here, xkcd web API. I think this might work. Let's see. Oh, this one. Sweet. Actually, this one has like weird formatting. Let's try to find another one. JSON. Oh, Json Placeholder. This is one that I've used before, I think. Guide. Okay, let's just do that. Yeah, this should work. Could actually just copy this whole thing out. I don't even need to define a variable, I'll just make the function call. So we have this fetch function, and you guys have not learned about fetch yet, I think, but maybe you would have, I don't remember. So it takes in some sort of URL from which you will sort of derive this resource in like a REST, it's a REST API endpoint, basically. In this case, we're using Json Placeholder, which is like a really simple REST API just used for like demonstration purposes. So if you go on this, you'll find, oops, so we don't want this there, but you'll find this sort of like randomized body in there. And it's not random, it's just this random like text. And then we're gonna get the response from that. And so this then right here is in itself like a promise. Essentially, we're getting something from fetch, and fetch, this function fetch returns a promise, which can be called to derive the actual contents of that. So a promise is just a contract that a developer makes with the machine that says, I will get the results of this call eventually at some point, and here's a promise that I'm going to get them. And so you might remember this from like a 61A like streams context. Sorry if I'm like constantly linking it back to 61A, but like a lot of these concepts are like very analogous. So you might remember it from like the context of streams, where you can get additional information at will, and sort of by defining a stream, you have like a promise to have the rest of the contents of the stream be read whenever you need them. Similarly, you can get the results of the fetch call whenever you need them. And the way to do that is to say promise.then, and then you put in the response, which is just like a random variable that you create for the sake of the function, for the sake of the arrow function. And so you're saying that this fetch thing will actually return this response. And so you take that response and you convert it to JSON, because right now it's just a string. So .json converts the string and de-stringifies it into JSON. And then you take the JSON itself and you log it. And so all of these processes are done in the context of promises. So I don't know what happened there. Let's see. Okay, so as you can see, it says promise, pending, undefined, and then finally we get our object. And that's because initially we get the results of this call, which is automatically sort of the first thing that is returned to the console is the output of the line. And then we have the actual output of the line, which we can get by say const promise equals, and then this, and then promise.then, and then all of the body of this, I guess, would remain the same. And so we have our object here, which is what we see over here, but in a way that JavaScript has interpreted it. Your user ID, title, and body. You have all of those things here. And we can save that to our own variable or anything like that. So that's kind of our special contract that we get to define. Yeah, Mira, does that make sense? Do you have any other questions?
No, I think I kind of get it. Thank you.
Cool. So yeah, as you saw, we have our ability to use .then to pass in two functions, one for the promise that resolves and one for the promise that rejects. So we have our on fulfillment and on rejection, which I'm actually not going to go into right now, but on fulfillment is a parameter that you can like optionally pass into then in order to allow us to handle a fulfillment clause and then a rejection clause. And that rejection clause only occurs if we catch some sort of error within our fetch body. So we can handle all errors that occur within any sort of statement within the promise by using .catch. This is just another way of doing it. Like alternatively, you can use on rejection as well. And you can say catch, and we can take our error and we can pipe it to whatever error message we want to, whatever error message you want to show. Anyway, I'm not going to go into that. Yeah, so that was kind of a lot of new information. So yeah, to answer Roman's question, we will have an attendance form, and I'll give it in a minute or two. Okay, so I'm going to go back to this. What is asynchronous? Yeah, so again,
thank you. Is that good? Bring it to the back.
somebody's not muted. Okay, so yeah, so again, a fetch data function or any sort of asynchronous function takes a long time, will not function the rest of the function calls, which is really good for web development because we don't want our users to just run away because all of our function calls are just taking too long. Instead, the content of the HTML content is going to finish rendering because that's part of like the synchronous body of our entire package. Cool. So does all of that make sense? As a review, I'm actually going to bring this up, and I have the answer right here, but I want one of you to just raise your hand and explain it to me. Otherwise, I'm going to call one of you out. Just sort of explaining what this means. Yeah. I'm going to give you guys like a minute while I pull up the attendance form, and then I want one of you to explain to me what's happening there. Well, I also realized that Kimberly has sent a very useful sort of overview of scoping. If you guys have any questions, I don't know if you've seen that yet, but it gives you a very clear difference between var and let, as well as scoping at large with examples. So take a look at the announcements channel for a message from Kimberly on the 27th for that. Do you guys usually get like attendance forms? Can someone answer that in the chat? I think I had one, but I don't see it here. Do get an attendance form. Interesting. Okay, got it. I will send it out after the lecture, just right afterwards. I haven't made the Google form yet. So anyway, the secret word is going to be await. So it looks like that. Wait. There we go. That's the secret word. And so after lecture, I'm going to send the Google form and you can put that in as your secret word. I hope I'm doing this right. Cool. So can I call on someone to, I will send the link, by the way, for the attendance form right after this call is over. Okay. Who wants to sort of explain this out loud? Yeah, it will be on Slack. Mira, do you want to explain this?
So kind of what I really understood, I mean, also just talking about this, but in generally for asynchronous functions, is basically that if you want something to happen before and you want something to happen after fixed like amount of time, that's when asynchronous functions are really useful. And so when you're like interacting, I guess, with server-side functions, you want some code, like you want your HTML code to just render as soon as you get on the web page, obviously. But like if you have some, if you want something else to render after some time, then it's useful because the user will see it after some time. So it's like it will kind of like pop out once you just see it versus something just appearing, kind of.
Yes, I guess that's like a good way of putting it. But yeah, we want to sort of highlight that promises allow us to sort of gather all those resources and then utilize them sort of at will, similar to the way we can sort of see it in other programming languages. So that's just something to note. So I'm actually going to, I got the URL. I will copy it and send it in chat now, and I'll also send it afterwards in the Slack. This is the form. It says it's not accepting responses. No idea what's going on here.
What if you just press resume collecting responses, the blue?
For some reason, it's redirecting back to lecture 3, which isn't what I want. Okay, I don't want to keep you guys here. I will send it afterwards in the Slack channel. So yeah, it shouldn't have been lecture 3 last time. It should be different ones for every lecture. But yeah, thank you guys for coming. Again, as always, if you have any questions, make sure to go to office hours, which are on the calendar. And make sure to start project 1.
Hi, is it okay if I ask a question?
Yeah, go ahead.
Um,
Yeah.
or like, can you
Well,
stop?
sorry, one
recording?
second.
Yeah.